Good morning, and thank you for joining us this morning. We are very excited to visit with you today and answer some questions as we discuss the effective use of unmanned aerial vehicles, or UAVs, in roof and pavement management program. My name is Eric Hazelbush. I'm the Director of Marketing at Benchmark, and I've got the pleasure of having Ben Fiedler, who is our Chief UAV Pilot and a consultant at Benchmark, with me today. We're looking forward to this. We've received several questions prior to the session today, but as we're going through today and you have questions come to mind, please submit those as you go. And yes, we will share the slides at the end of the presentation, or you will get them sent to you, so you will have access to those slides. But with that, we're going to go ahead and move on today. And we'll touch on just a couple slides, at least let you know who Benchmark is, for those of you who may not know. But we are a roof and pavement consulting firm. We've been around for around 30 years. We are an independent firm. We're privately owned. We have 4 primary services: evaluation of roof and pavement, design and bid services, construction phase services. Think about eyes in the field for our clients or prospects, and then program management. Our offices, primary offices, are in Cedar Rapids, Iowa, and Waukesha, Wisconsin, or Milwaukee, and we have 21 satellite locations. Today, I think we have 115 employees. So I'd like to tell you a little bit about what makes Benchmark, we believe makes Benchmark unique. And there are 3 things. And Ben, I'm not seeing the slides progress.
Can you hear me right now?
This just a second while Ben comes back on. Go ahead. Okay. Thank you, Jennifer. It looks like you can see and hear us. That's positive. Ben, can you pull that back up, please?
Yep. Sorry about that. My internet unfortunately dropped out right as we got started there.
Okay, we'll continue on. And there are 3 things I think make Benchmark unique. Number 1 is technical excellence. Number 2 is client focus. Number 3 is organizational health. And by technical excellence, we deliver independent information, and everybody in our company is focused on being market leading, providing market leading consulting services, so you can trust the information we provide you. Number 2, it's really focused on, can we understand your goals and create long-term shared value? We look at this as a partnership. We want to have win-win situations. And number 3, organizational health. And some people think this is kind of unique, but when we find that team members in our team get along, want to work together, want to play together, all those things, and we have a unified purpose of serving our clients, we can provide you with information and that you can be confident and trust. So, and all that results in the promise we make to our clients, which is we will always keep your best interest in mind in everything we do. So that is all we're going to talk about Benchmark today. The rest is going to focus on the content. So let's take a look at what we're going to cover, Ben. 4 things we're going to touch on today. The first is a foundation of knowledge. When you start thinking about UAVs and drones, a lot of terminology, a lot of words are used interchangeably. People don't understand some of the terms. So we want to make sure we have a foundation of knowledge everyone can build from. Number 2, we're going to talk about how do you apply and use UAVs in a roof or pavement management program. Number 3, we're going to share some real life case studies. What's happening in the real world? How are we applying UAVs? And then finally, we'll take some time for Q&As. With that, Ben, let's go ahead and touch on the foundation of knowledge.
All right. So the first thing we're going to talk about is what is a UAV. And so you're going to hear throughout this presentation, we'll talk about drones, we'll talk about UAVs. And for the most part, they are one and the same. However, a drone would include any remote controlled vehicle. So that could be a submarine. It could be some of those land-based. Boston Dynamics has their dog-looking robots. Those are all also considered drones. A UAV is a drone that flies. So it's anything that's flying that is unmanned. So for the most part, they are interchangeable, but we want to start off just setting the record straight on that. So for Benchmark, our drone, we have the Matrice 300. We have nicknamed it Captain Haynes, and we have 2 different types of cameras for it. The first one is the ZenMuse H20T, which is an infrared camera. It also has a 200 times zoom camera on it. So when we're doing a survey with the drone, we can really reach out there and take some really close-up photos while the drone stays far away. The other camera is the P1, which is a purpose-built survey camera. So it is engineered to take the best photos for the purpose of creating digital models, maps, all of the things that we're using it for. It's purpose-built just for that application. The next thing we're going to talk about are orthomosaics, which an orthomosaic is a series of photos that are taken 90 degrees from the ground that are all stitched together to create one large image similar to Google Earth. There is a technical difference between stitching and an orthomosaic, because during this process, it's actually recombining all the photos pixel by pixel so that there aren't sharp edges between the photos. And so for an example, here is a orthomosaic from our office. And so you can see along the edges here, there is a slight color difference. The edge around on the sides, that's actually from Google Earth. This different color, the more fall looking image, is from the drone. And so this orthomosaic is comprised of all these different photos. So each blue dot represents a different place the drone was when it took a photo. So you can see there's about 100 photos that are used to create this one orthomosaic. And so if you look in, for example, it's this dot here, the photo that is used on that location looks something like this. And so the software goes through and recombines all of those photos to build one large image. And I do apologize, my home internet did drop out right as we were getting started there. So I am running on a cell phone hotspot right now. So if there are any audio difficulties, just let me know. I can see in the chat that I was lagging for a second there. So the next topic we're going to talk about are the types of orthomosaics that we are creating. The first one is an RGB, or a red, green, blue orthomosaic. And so these are orthomosaics that are comprised of visible light photos. So these are your typical photos you'd see on any type of camera. And so those are the images that are just in the visible light spectrum. The other type of orthomosaic is the infrared or thermal orthomosaic, which is from a camera, the infrared camera, that's using infralight spectrums. And so that's what we use to identify wet insolation. So now we have some orthomosaic definitions out of the way. We're going to move into some of the legal side of the drone industry. So the first one being the FAA, which is the Federal Aviation Administration. So in the United States, this is the government body responsible for managing the laws and practices around any aviation. Every country is different. So Canada is regulated by Transport Canada, and because of that, every country has different drone laws. So for the purposes of this presentation, we are only focusing on the United States and the FAA. So for the FAA, all the laws are contained within 14 CFR Part 107, which is a long, kind of confusing term. Everybody calls it just Part 107. And that's the law that regulates drones specifically. So anything within Part 107 are the laws corresponding to the drone.
Let's go ahead and take a look at our first poll question. And we have many clients that have drones or UAVs. So we'd like to find out, does your company have licensed UAV pilots on staff? And as that poll question pops up, it's a pretty quick and simple to answer poll. So please answer yes, no, or planning on adding them in the future. And I think Ben turned off his video. Hopefully that will help clear up some of the audio issues. So we'll give this just a few more seconds, and then we'll go ahead and close this and see what our answer is.
All right, looks like most of the responses are in, so I will end that and share results.
So it looks like 41% of companies have licensed UAV pilots on staff, 51 do not, and another 7% are looking at adding them. And that's kind of what we're seeing right now. I think it's really interesting, especially when you get into some of the qualifications of what's required of a skilled and qualified pilot. So we're gonna go ahead and take a look at some of those qualifications right now.
We're going to break this down into three main categories of qualifications of a pilot. The first one being the FAA licensing required for that pilot, the insurance for the drone operations, as well as the skill of the pilot themselves. So earlier I mentioned 14 CFR Part 107. And so this is a small snippet of that legal document that pertains to who needs to have a license. And so there's a lot of text here, but the pieces that I have bolded are the critical pieces. So first, no person may manipulate the flight controls of a small unmanned aircraft system unless that person has a remote pilot certificate. There are exceptions for recreational use that if you're flying for a non-business purpose, you actually don't need to have that certificate. However, the FAA has deemed that a flight to be considered commercial is if there is any furtherance of a business, not just for financial compensation. So for example, a flight that may involve goodwill or doing a favor for somebody is considered to be commercial and would require a Part 107 certificate. Another key piece of that regulation is that it requires the pilot to actually have a physical copy of their certificate with them at all times. And so it looks a little bit like a driver's license. It's issued by the Department of Transportation. You are required to have a copy of that with you anytime you are operating the drone. So if somebody is going to be flying a drone at your site, that is a very easy way to identify if they're qualified or not. Do they have a physical copy of their license or certificate with them at the time of the flight? The next piece is insurance. And so first off, the FAA does not require insurance for UAV operators. Some states like Minnesota do have requirements to have insurance, but that is a fairly rare thing. By and large, there is very little requirement to have insurance. And so it's a good idea to be making sure that your drone operators have liability insurance for damage caused by the UAV. So if there was an accident, if they were to crash into a power substation, anything like that, as well as photographic liability. Because it is a photography service, there is a special type of insurance that must be carried for the photographic side of that. Additionally, there is hull insurance for drones, which is basically, if you crash the drone, your liability insurance will cover the damage to the item it crashed into. Hull insurance covers the damage to the drone itself. Those are insured separately. So there's really three types of insurance a drone operator needs to have. The last piece is the pilot skill. So the Part 107 certificate is really focused to make sure the pilot has an understanding of the national airspace system. It's about, my guess is it's 75 to 80% focused just on how do you fly, where do you fly, what are the conditions you can fly in. There is no proof of performance requirement to receive the certificate. You never actually have to touch a drone in order to get your remote pilot certificate. There is a test involved that you have to pass. It is admittedly quite challenging because you have to know all your airspace, but you never are flying the drone. And so you need to ask, have the pilots flown anything similar to this type of a project? They're flying an infrared flight at night. Have they done this before? Have they flown this particular UAV before? Do they have flight logs that they can show you? How often have they flown these types of missions and these types of drones? Additionally, because they are looking at complex things as they're flying, they're needing to look and understand what they're looking at. They need to have roof and pavement specific knowledge. And so one of those big pieces on the roofing side is understanding complex infrared windows. Not all roof systems look the same, and they all can look slightly different with what their signatures show. So this is an example that I pulled. And so when you look at it, there's a couple main areas that right off the bat I look at and suspect there would be wet insulation. The first one's right up here at the top. You have this this large orange blob showing up. And in these infrared images, the orange or yellow is the hottest color, purple is the coldest. So there isn't a temperature scale on this image, but just know yellow is hot, purple is cold. And so typically wet insulation will show up as yellow or orange. And so if you look down below, there's another spot right here. That also looks like a wet insulation signature. And after we went on the roof and cut cores, we were able to identify this top area is wet insulation. And this bottom area is actually a roof repair that they used a different type of insulation. So because there was a different type of insulation, the signature looks slightly different. And just for your reference, this big blob over here, there's an exhaust fan on the side of that building, so it's exhausting hot air out on the roof.
So Ben, how many miles or how many flights have we flown?
I think we're over 500 miles flown. I've lost track of the total number of flights, but it's several thousand individual flights going on.
No, thank you. But I think the points Ben made, a lot of technical information, a lot of FAA information, but it's really pretty simple. Does the pilot have remote pilot certificates? Do they have that? Are they insured? And most importantly, do they have the skills to help you reduce risk and increase the long-term performance of your assets? It's combining the technology of the UAV and the data collected with the UAV with the experience of that pilot to help you manage those risks. So let's take a look at how we can use UAVs in a roof management program, how we can apply that. The first thing we'll talk about is the infrared and thermal moisture survey. Ben shared one image of that, but what we've learned with UAVs, we can cover large facilities, in many cases, million plus square foot facilities relatively quickly. Number two, we can really quantify that wet insulation. And when we have an accurate orthomosaic or imagery, we can quantify the amount of wet insulation on that roof. And risk is a huge issue today. The risk of not having people walking across your roof at night in the dark is greatly reduced when we can fly with a UAV versus handheld. Both options, but it does reduce risk when we fly with the UAV. But I think the main point is it still requires field verification, whether it's with capacitance meter or core samples, because there's so many things you can see and not see with a UAV that can be misleading. So you'll see some of those things in the case studies, but let's take a look at how we can use this continued in a roof management program.
So this is another infrared image that I pulled. And so yet again, you can see a couple pretty obvious signatures. We did do core samples. We verified that this area here and this area here were both confirmed to be wet insulation. So within the drone software, you can then go in and draw over those areas a shape that will tell you exactly the size of the wet insulation. So in this case, that larger area is 170.29 square feet of wet insulation. And so we've eliminated the need for a consultant to be on the roof measuring, locating where is this insulation. But furthermore, if you do end up having a contractor come in to remove that wet insulation, we can also give them dimensions to zero in on where do they need to start removing insulation. We can tell them that it's 14 feet 6 inches off the south wall, and it's a total of 10 feet wide, and they can very easily go to the roof and find that exact location.
Thanks, Ben. We took a look at some infrared images, and you'll see some more in some case studies, but let's take a look and talk about RGB orthomosaic images and how we can use those. And it's really the ability to create highly accurate maps for dimensioning, and what you can see is really quite amazing, and then how to use that information as well.
So this first sample that I have, I'm showing you a comparison of 3 different images of the same roof drain. And so on the left here, we have the 45 megapixel image. So that was taken with the P1 mapping camera on our drone. The image in the middle is a 12 megapixel image. So that was taken with a smaller, cheaper drone. And then the image on the right is from Google Earth. And so as you can see here, there's a quite an extreme difference in quality. One of the things I like to point out on this image is right here, you can actually see our office is right on a golf course. And so while during the day, we end up with quite a few golf balls on the roof of our building. And so in this case, one found its way to the drain. You can actually see the golf ball in the drain. On this image, you can see that there might be something there. If you didn't have this image to compare to, you probably wouldn't have known that that was a golf ball. And obviously with Google Earth, there is no chance you will ever see something as small as a golf ball. However, so to show you for comparison's sake, I had to stay zoomed out a little ways because there was a point at which Google Earth, it just kind of became worthless and you weren't really able to see any of the detail. But the 45 megapixel image, we could still zoom in further. And so I went ahead and zoomed all the way into the drain. And so now you can see that that drain, it's getting a little pixelated. It's getting hard to see, but you're still able to see quite a bit of detail. You can see the openings in the drain strainer. The 12 megapixel image, you might know that it's a drain strainer, but you can't see that it's any of the fine detail. Google Earth, you really can't see anything at all. We did just get a question asking how high were these images taken. The drone images were 175 feet above ground level. Google Earth is obviously satellite based. But this really goes to show the difference that the higher quality drones can make. The next example I'm going to show you is how we can use these for measuring. And so as you look, there's this blue line that I have drawn across the roof. And you can see on the left that that's 107.39 feet long. The next slide, I'll show you how I have quantified that in the past. But that is a measurement. We can get up there on the roof. We can pull a tape measure. You can verify that it's accurate. The software does tell you your known accuracy. So you have pretty good confidence of the results of the measurements. But the thing that I find very interesting about this measurement is it also captures three-dimensional information. And so right here in the corner of this roof, we have tapered insulation for drainage purposes. And you can actually see a little bit of the water runoff from this unit. You can actually see where the water runs and really shows you the corner of where that tapered insulation exists. But if we start to look over here at the slope profile of the roof, you can see, so this point here would correspond to this side. You can see the slope running downhill, and then you can start to see the slope going back uphill. So you're able to see something as small as 1/8 inch tapered insulation. Earlier, I mentioned a way to verify the measurements. It sounds like I may be lagging. I think it's working better now. During a recent project, though, I was flying at a high school that had a football field. So I went ahead and flew it, drew my line because I knew that that was a known dimension. My measurement came in at 300.14 feet. So very easy way to verify your measurements in addition to other verification methods.
So we talked about infrared, we talked about RGB, and now just imagine for a second, you're sitting in your office and you've got a project you're working on, and you've got engineers across the country, and as many clients we work with do. You now have the ability to, through using imagery and platforms, to talk through projects, whether it's a pre-construction meeting, whether it's a pre-planning meeting, whether it's meetings thinking about you're going to remodel a facility and make changes to the roofs from inside processes. You get a lot of really good information that you can use. And now Ben's going to share some 3D modeling, what we can do with 3D modeling, and what some of those things would look like and how you can apply that as well.
Yeah, so this video here, this is a 3D model of a building here in town. So this was taken before construction, so you can see the insulation there. You can see that you can very easily start to visualize what does the facility look like. You can be able to plan roof access points. Where are you going to stage materials? You can see that, hey, we'll use a man lift to get people up here, or where are we going to store equipment around the entire site? All of those types of things can be very easily visualized with that digital twin.
And Ben, it's important to point out that that is not a video that you were seeing, because as you think about a video, maybe not be quite as clear as you would hope. That's a 3D rendered model based on millions of data points. And
Correct.
you want to touch on that a little bit more, Ben?
Yeah, so before this webinar, I went in and I just did a screen recording to show you as I panned around, just to make sure that it would work well. But from this model, you're able to zoom in anywhere you want. We have a client that's using this technology to map out their refrigeration lines, their ammonia lines. And so from that 3D model, they're able to virtually walk the roof, and their designers in their office are able to read the labels on the piping from that 3D model. And so there's a lot of really great applications from this model, as well as just it's a great way to show off your building. This roof is now complete. My plan is to go out there and recapture this. And then the owners have this beautiful model of their building. They can see what it looks like from that bird's eye view.
And they can apply that to their with their internal design systems as well. So we've touched on infrared, we've touched on RGB, we've just touched on 3D models. Ben, you want to take the question on special software required? And maybe Ben can't hear right now, so I'm going to continue on.
No, there's quite a few different software systems out there, and so that's kind of a hard question to answer, because there's a lot of other variables in place. You kind of have to evaluate each different platform for what they offer and compare it to what you need. And so I can give you a list of softwares. It's hard to give a recommendation without a lot more information.
Thanks, Ben. So the next thing we're going to talk about is inaccessible and dangerous roofs. You know, unfortunately, there are cases we get to sites or talk with companies, and they have roofs that just are not safe to access, whether there's structural issues, whether there's roof-related issues, and you can't walk on the roofs. You can't physically walk on the roofs. We've found that we can use the UAV for surveys in those areas, and we'll take a look at what that looks like. And the other area is when you may have some extremely tall buildings where there just aren't access points. And the cost to access the roof would be so great, it's just not worth it. So we do an initial evaluation with a UAV, and there may be some additional required follow-up to that, but at least we can start there on those type of roofs as well. And we'll take a look at a couple examples here.
So yeah, these images were taken on a survey for a metal, a facility with all metal roofs on it. And so this is an image that was taken from the drone. Having that long telephoto lens on the drone allows us to keep the drone back a good safe distance, but still be able to zoom in to the point where you can very easily see the corrosion on those fastener heads. You can see the sealant on the joints of the metal. So you're able to see quite a few things from that drone. However, there's also things you can't see, right? So there should be a foam closure on on the cap. You can't feel behind the metal to see if that foam closure is there. On the metal inlaps, you can oftentimes get corrosion on the underside of the panel. And so one of the things a consultant on the roof would do is walk that inlap and listen to see if it sounds crunchy, or possibly even disassemble that inlap altogether. The drone can't do that. You know, my goal, my hope is by the time I retire that there's a technology that can do that. But that's the long-term view. That's not where we are right now. But in the meantime, we can reduce risk by getting at least some level of information remotely. This is another example of it was the gutter on the site. You can see there the gutter brackets were actually pulling loose. This is one of those photos that it's hard to take anytime. So even if you are doing a boots on the roof survey, getting information around that perimeter edge, if you have a site requirement that it's impossible for us to access the edges, a drone can fill in the gaps. This is another gutter issue where you're able to see that those the gutter joints are breaking free. That might even be difficult to see from the roof. Depending on your line of sight to it, you may not see that if you're standing directly on. By having the drone overhead, you can get a better view on it. So one thing I wanted to point out that during the survey, during a drone-only survey, our traditional model, the way we go about these surveys is we actually send out 2 consultants. So the first one being the drone pilot, whose only job it is to keep the drone flying safely, to get the drone where the other consultant can use it. The other consultant's job is to then to sit there and watch the video feed on a large monitor so that they can focus just on looking for defects. That way the 2 can work as a team. There's a division of labor so that everybody is really just dedicated to the one thing they need to do best at that time. And so this is an image that was taken during a survey where the other consultant took a photo of me flying the drone around, but it gives you an idea of what that process can look like.
And I think that's a really important process because we talk about having boots on the ground, and the example Ben just shared was in a situation where we can't get on the roof, either inaccessible or not safe to get on. It's having someone that can focus their attention on analyzing what they're seeing. So when we leave the site, we've captured the information or captured the data that we need at that time. So we've spent some time talking about UAVs and how it can apply in roofing. Let's talk a little bit about paving now, and we're going to touch on land surveying. As you've seen with the point cloud 3D model Ben showed and some of the other images, we're capturing millions of data points. And so let's see what that looks like and how it can be applied to pavement.
So I'm going to start off this by zooming in to an incredible close detail. So this is an image that I captured of a pavement, and you can see there was a crack that had been sealed. And so along the left on the surface model, yet again where this white dot shows up, corresponds to right here to that little jump in elevation. And so this is a pretty extreme example of seeing changes in elevation. But the reason why I want to show that is this shows you the kind of resolution that we can see when it comes to pavement, slope, and drainage design. So that when you zoom out and you can see the entire site, it makes your understanding of what kind of data you have a lot easier to see. And so in this case, you can see along the bottom edge of this parking lot, water is flowing from the right side to the left, down along this drainage swale out to the creek. And then on this side of the parking lot, the water is draining this way, yet again, down towards the creek. So you're able to very easily identify if you have a low spot in your pavement. You can see all of your site in comparison so that if you're replacing maybe only one section, you can see the impact of drainage of one pavement to the other.
And that is as Ben talks about that for pavement, I think the other thing is unique, and I may have mentioned that a little bit earlier, I can't remember, but as you look at the picture on the right, that is our roof, and it has a quilt effect because we put multiple roof systems on there so we can evaluate those roofs over the next 20 plus years of service life.
So one thing I do want to touch on is kind of getting into the weeds a little bit of how is this data generated? How does the computer model know what these elevations look like? And that's from a point cloud. And so once again, this is a point cloud of a building. It looks similar to an image, but as you notice, and you look closer specifically at the building, you can see through the building to a certain extent. And that's because this image is made up of millions of individual points. And each of those points represent a space, a point in space. It has an X coordinate, a Y coordinate, and an elevation coordinate, as well as a color assigned to it. So if you blow that image up, you can actually start to see each of those points that are put together to make that model. And so the computer system can look at that and see how are each of the points in comparison to each other to determine that slope.
So as we talked about land surveying, and Ben just shared the vast number of data points used to build models, we can also use the UAV for lighting surveys. And we're not doing quantitative, but in this case, we've done some qualitative analysis, and we'll show that when we get to a case study.
And so the next section up will be case studies, but before we get there, I had a little bit of a soapbox that I wanted to get on and talk about the difference between data and information. And so I recently read the book called The Goal by Eli Goldratt. And if you're in a process manufacturing type environment, you're more than likely familiar with that book. And in the book, Eli writes, I previously thought of information as a section of the data used to make a decision. And later he realizes information is the answer to the question asked. And so if the question is, what condition are my roof and pavement assets? The data that the drone provides isn't going to answer that question. You're going to have analysis by somebody, preferably an expert, that can answer that question using that data. The drones they capture just a tremendous amount of data quickly, safely. I mean, it's amazing. Every day it blows me away what we can do with the drone. However, until you apply knowledge, analysis, and additional field data from that expert, they cannot convert that information, that data, into actionable information. And so with that, we'll go ahead and get started into our case studies.
So let's take a look at our first case study. And it's really important you pay attention here because I want you to look at the top right and then the lower right. The top right, we have an RGB image of this roof. It's fairly detailed. And below that, we have an infrared image. And the question we're going to ask you to answer is, what type of roof system is this? Based on what you saw in that image from the drone, what type of roof system is that? So let's go ahead and share this question. We have options are a coated metal roof, white single ply, spray polyurethane, and a coated modified bitumen. So give that some thought as you saw those photos. What type of roof system do you think this is? Okay, Ben, let's go ahead and
we're still getting quite a few responses.
Okay.
I'm gonna give it another couple seconds.
Perfect.
They're still flying in.
A lot of analysis taking place on this. That's good.
All right, we'll go ahead and end that, and I will share the results.
So we have a coated metal roof. 40% of you coated metal roof, white single ply, 27% spray polyurethane, 7%, and coated modified bitumen, 27%. Let's take a look at what the answer is, and we'll talk about this a little bit. The correct answer is, it is a single ply modified bitumen roof system with an aluminum coating. And so what's taking place here? And 40% of people thought it was a metal roof. And I can tell you, when we had this discussion internally, when you look at these images, at first glance, you're like, yeah, it looks like it could be a metal roof. Until we dug deeper and got on that roof, took a core sample, and understood what it was. And so why was that? Well, the membrane ran parallel to the slope, and there was a control joint installed at the ridge. So that's why it was easy to appear that it might be a metal roof. And that is why it is so critical that we have boots on the ground, because in this case of our audience, 40% would have, more than 40%, probably, what was it, close to 70% would have identified this roof incorrectly. So it's easy to happen, and this is just one example of why it's so important you mirror the data collected from a drone with the expertise and analysis of an expert and have boots on the ground. So that's case number one. Let's go ahead and look at some more case studies, Ben.
So this was another infrared that I did that I got done with it, had it processed. I'm looking at it, and I just didn't know what I was looking at. It tried to look like wet insulation, but the signature was just different. It didn't have a nice board pattern to it. I knew something wasn't adding up. So the question I had was, is this interply, wet insulation, both, or neither? So with that, I will launch this poll question.
So our options are, what is this infrared signature showing? Interply moisture, wet insulation, both, or neither?
Getting quite a few results in, give it a few more seconds.
And while you're answering this, if you have other questions that come to mind, feel free to shoot those, send those in.
All right, looks like most results are in, and I will share the results.
24% identified as interply moisture, 5% wet insulation, 27% both, and 43% neither. So Ben, why don't you share what you learned on this roof?
So after I did the flight, the next day I got up there and I ended up cutting some cores. And so the results, it turns out this roof system was somewhat unique in that the existing roof was TPO, that a few years earlier, they had then covered it again with another layer of TPO with membrane directly to membrane. And so normally you would see a layer of insulation there, but in this case, you effectively had a 2-ply TPO roof system. And so as the top layer would leak, water would get between the membrane plies and would spread out across the roof. It would then find another leak in the old roof system and then leak down, and the insulation below would also become saturated. And so in this case, it truly was both. It was interply moisture, and that's really prevalent. You can see here, you can actually see the moisture sitting between the mechanical fastened seams. And then over in these areas, you can actually see where it starts to become more muddy. That's because that's where you see both. You have interply and you have wet insulation. Both signatures are showing through. And so it's one of those that the core samples really were able to answer the question, what condition is my roof?
And Ben, what else did we learn? Had we not done core samples, what else could have potentially happened as a result of this? Or what else did we learn from the core samples?
Well, so the big thing that comes with wet insulation is typically, like in this situation, a large portion of the roof was wet. And so the next discussion is, do you replace the wet insulation or do you replace the entire roof? However, once we cut the cores and we found that there were already 2 layers of TPO membrane, by code, it meant that we had to replace the roof. So we could either replace wet insulation or replace the roof. The infrared eliminated, or the core sample eliminated the option of doing a recover in this situation. So earlier, Eric mentioned the lighting survey for pavement use. And so as you can see on the right, we flew the site and we were doing an infrared at night. And so we also were capturing the RGB images at the same time of the pavement areas. And so in that image, you can see there's a couple areas that are quite bright and a couple areas that are quite dark. And so as the site was considering adding additional parking stalls, they were able to look at the lighting to figure out if they were going to need to add additional lighting. And in this case, they realized where they were adding parking stalls was actually already well lit. And so they were able to not have to add additional lights to maintain safety. And so this is a great way to be able to get a really good high level view of lighting. Obviously, in a lighting situation, you do need to have actual measurements. But the hard part with those is they're very spot specific. As you're walking around, you're holding a handheld meter, taking individual readings. The drone helps you kind of start to see where do you need to look for problem areas. The fourth case study that we have is another infrared. Those I find have some of the most interesting aspects to them. And so this is an infrared. The first time I flew it, the daytime high temperature was 89. The time of the scan, it was 75 degrees, which means we had a temperature differential of 14 degrees, which is really quite good. The wind speed that day was about 6 miles an hour. And that afternoon, we did have a little bit of rain, very light rain. I actually have done infrareds while it was raining, and then later confirmed that the results were still accurate. So all of those conditions led me to believe that the conditions were right to do an infrared. However, as you can see in the image, you can definitely see there's wet insulation, but it's not nearly as clear as a lot of those other images I shared. So with Benchmark being really dedicated to being technically excellent, I went ahead and went back and flew it the next night. And this is the result of that second flight. So on this flight, the high temperature was 91, the time of scan temperature was 82. So we have a much smaller temperature differential. The wind speed was slightly higher, and there was no precipitation that day. However, when you compare the images, you can really tell that second flight really gave a much easier to read image. They're both accurate. You can see the same wet insulation on both, but that second one is just, you're able to do analysis a little bit easier on.
And
So
Ben, go ahead, finish, Ben.
So the moral of the story is you can do infrareds with some rain. You can do infrareds with higher wind. You can do infrareds with small temperature differentials. You can't just look at any one of those conditions individually. You really have to look at the whole condition of the flight as a whole, as well as look at the images after the fact.
I think this is also an example, and there are times we go out, whether it's RGB or infrared images, or even doing consulting work, where things just don't always add up. And it's an opportunity to really dig into things and understand, why are we seeing what we see? Because it's not always just black and white as to what's happening on a roof or what's happening to a pavement. It takes time and just thought to try to dig into those things. And as we continue to build on using UAVs and mirroring that and tying that into consulting, there's gonna be a lot more things we're gonna learn. And so it's just really important that whoever you're working with has a mindset of wanting to learn how to improve the process and how to always make it better, because you can't just take the data that comes in from a drone and assume that it's accurate. So go ahead, continue, Ben.
One more case study?
Yeah. Case study 5 is, we talked about difficult access roofs. In this case, if you look at this drawing to the right-hand side, that center roof is 133 feet high with no access. And the cost to access that roof by a person is just not realistic. And so in this case, we used the UAV to survey that roof, as well as some of the units around that roof, to give the client some insight to what we're seeing, what's going on. And then, depending on what was discovered, you may have to spend the money to get up on there physically. But at least it's a way to start to gather some data and then analyze that data to make some recommendations before you move forward.
All right, we're going to get some question and answer time. We did have, I think, about 5 questions that were asked previously that we're going to go ahead and get into it. And then there are a few that I do want to answer that have came in during the webinar, but feel free to continue to ask questions. We'd love to answer them. There are some questions that we may not have time for, and so we will make sure to circle back with you and answer those questions for you individually. So the first question was, can a drone be used to view and inspect rooftop equipment? And so this is actually the same roof plan that Eric was talking about earlier for a drone-only survey for a very difficult access location. Well, it turns out that roof, that high roof section there were 2 exhaust fans that the site contact asked us to take some photos of. And so while I was flying, I was able to take photos, and the units had actually fallen over in a windstorm. And so we were able to take some great photos, pass those along. That way the client could determine how they're going to repair those units.
Now, the second question, what are possible business cases to offer savings with roof replacements? And, savings may not be the word, but it's having accurate data and information. And when you think about replacements, knowing, is there wet insulation? being able to accurately define and quantify the amount of wet insulation. It gives you an understanding of slope before you get there, helps you identify and understanding potential drainage issues you may be dealing with. And so the wet IR is probably the biggest one, wet insulation, where you can determine, can you replace or recover that roof? What are your options? Works well. So let's look at the next question.
I had a question of what are the permission requirements when flying over commercial properties? So the first view of this, so federally, the only requirements for where you can and cannot fly are airspace requirements. So adjacent to airports, you have issues there. There are some no-fly zones. Washington, D.C. is a no drone zone. National parks are no drone zones. So on the federal level, there's not all that much specific requirements for flying over somebody's properties, which means that a lot of the country, you can fly a drone over somebody else's property without permission. I do want to point out, Benchmark would never do that. That is one side of the drone industry that's a little uncomfortable, because legally you can, but morally it's not right. There are some states like Texas that you do have to have explicit permission to fly, but that's not everywhere. In Iowa, you can fly over anybody else's properties and be fully legal doing so.
So what are other benefits Benchmark's clients have seen from using UAV? We touched on a few. We touched on reduced risk of having people on the roofs at night doing an infrared scan. We've touched on high quality images that can be used for planning. You know, imagine if you're doing pre-bid, pre-construction meetings, as well as internal meetings for future planning at the site. But you can also start thinking about, as we talked about, foundational information or foundational data. Imagine if you have good RGB images, good infrared images in 2022, and now you look at 2023 through 2025 to 2030, and you have a series of these images. And as we continue to improve the technology, we can look at change detection. What changes do we see on your roofs or on your pavement from 2022 to 2023, 24, 25, 26? And so I think there's a foundation to start with, having baseline information you can build from, because as the technology continues to evolve and grow, we will be able to do that in probably not too long a distance. So I think that's one other thing that could be a real benefit and value of having this information as a baseline. What is the pricing structure for a UAV survey? We get questions like that a lot, and it depends. And in the case of how we price for UAVs, it depends on the services that are required. And we sit down one by one and talk with our clients to determine what data they need and what information they need as a result. And then we will build a price structure accordingly based on specific needs. It really depends on the facility, depends on location, depends on lots of different factors. So we price them one-off based on the situation and needs of the client.
One good example of that was I was doing a project out in California that was near an airport. The FAA limited my altitude, and as a result, the infrared took a significantly longer amount of time as if I were able to fly at the maximum altitude of 400 feet. And so airspace can really change the duration of that project. I'm going to stop sharing my screen real quick, but we do still have a few more questions. And I want to kind of go back. There was a question earlier about software for the drone data, and I think I may have answered it with a different perspective. One thing I want to point out is when Benchmark flies the site and we're delivering back the data to you, that data is available in an online platform that you're able to use to look at the images, to look at the models. And furthermore, Benchmark has a very strong history of the data we have about your facility is your data and you can have access to it. And so if you have a existing design team that's using something like AutoCAD, Revit, we can give you exports that you can take right into those design softwares, such as those point clouds, those digital elevation models, all of that, we can give you those exports out of the drone software so that you can bring it right into any system that you're using. And so you can view it there.
Ben, I'll take a question came in related to, do roofs need to be replaced based on an expired warranty? And it's quite often we see companies will replace roofs based on warranty length. My warranty is a 10-year, 15-year, 20-year warranty. And based on the warranty expiring, we're going to schedule to replace that roof. Our view is that warranty length does not equate to roof performance. If your roof was designed correctly, installed correctly, and maintained, roofs can perform a long time. And so our basis is based on, let's visually understand the condition of that roof. Let's take an infrared survey so we can see if any moisture's got in that roof. And then we can evaluate how long that roof will last. And warranty, it just doesn't play into that sometimes. We think warranties are overrated in some cases. Because if your roof is designed and installed and maintained, you should not just base replacement on warranty. You should base it on having facts and information to determine what's the condition of that roof and does it or does it not need replaced. Ben, any other questions you want to take right now? Looks like we've got about 2 minutes left.
No, I am not seeing any others coming in live. There are a couple we will respond to you directly, specifically about, there are a couple asking about viewing a model. We have some demos that we can actually send you so you can actually see what does that look like. So we will be following up with a few of you.
So with that, as Ben indicated, we will follow up with the questions we did not get answered today. But if you have other questions, please feel free to reach out to Benchmark or send additional questions in. We thank you for your time today. We appreciate you joining us, and have a safe and successful rest of your day today. Thank you.